Okay, let's dive in.
Right.
Today we're connecting dots between something, maybe stressing you out in class right now, calculus,
hmm
and something really vital happening out in the real world, regenerative farming.
Yeah, we've looked at some material, and it really zeroes in on hmm, a fascinating application of calculus.
Which is,
Specifically, how integration, that part of calculus, is used
okay,
to figure out the total amount of carbon stored in the soil by cover crops.
cover crops, right.
Uh,
So our mission, sort of for this deep dive, is to get why, not just that they use integration, but why it's like the right tool.
Exactly.
We want to make that link super clear for you, whether you're like neck deep in integrals or just curious about math out in the wild.
Well, you know how in calculus, integration is fundamentally about finding a total amount, right?
Yeah.
When you know how fast something's changing its rate, or maybe how quantity varies across space.
Right, right. It's not just the slope at one point, that's
Well,
differentiation,
okay.
yeah.
That's differentiation territory, precisely.
You're summing things up, little pieces, to get a total, or like the area under a curve.
Got it. Now, think about regenerative farming.
Okay.
The whole system is focused on making the soil healthier, and they often use cover crops.
Those plants, they grow between the main harvest, right, to
Yes.
protect the soil.
Exactly. Protect and enrich it. And a huge goal, especially with cover crops in these systems, is pulling CO2 out of the air.
And storing it, storing the carbon in the soil.
Yes. But here's the key thing, that carbon storage, it isn't just one fixed number.
Ah, okay, it changes.
It accumulates.
Mm-hmm.
Over time, as the plants grow, add organic matter.
Mm-hmm.
Or,
Yeah.
or maybe the amount of carbon is just different from one spot in the field to another. Depends on the soil, the water.
Right, soil type, moisture, maybe what happened there before, lots of variables.
Uh-huh. So if you want the total carbon taken up, sequestered, by those crops over a whole season,
Or across the entire field.
yeah, then just one measurement or even a simple average, it's probably not going to be accurate enough.
Because it's changing all the time, or all over the place.
You need a way to sum up something that's, well, dynamic,
Mm-hmm.
constantly changing or spatially variable.
And let me guess, integration.
And that is precisely where integration comes in. It's the tool for the job.
How so?
Well, imagine researchers can measure the rate carbon is being added. Maybe they take soil samples regularly, analyze them.
Okay, so they get a rate of change over time.
Exactly. If they integrate that rate function over, say, the whole time the cover crop was growing,
They get the total carbon added during that period.
bingo, the total accumulation.
Ah, okay, so it's like you integrate velocity to get total distance.
That's a great analogy, yeah.
But here it's integrating a carbon accumulation rate to get total carbon stored.
Precisely that. Or think spatially. Maybe they map carbon density across the field.
Like taking samples at different GPS points?
Could be. Then they might need to do a spatial integration over the whole area of the field.
To get the total carbon within that boundary.
Yeah, it's kind of like finding the volume of carbon under that map, that surface of carbon density.
Wow, okay, that really clicks. It takes that abstract idea from class, integrating a function,
Uh-huh.
and applies it directly
Mm-hmm.
to something real, tangible, and important, like measuring carbon pulled into the soil.
It really does.
It stops being just a test question, doesn't it? It becomes a tool
Mhm.
for like ecological accounting.
Absolutely. It shows these powerful math techniques aren't just theory. They give us the rigorous way we need to measure the actual impact.
The impact of practices like regenerative farming?
Yeah, and quantify their contribution to big goals like, climate change mitigation. It's using math to make smarter choices about land use.
Okay, so pulling this all together then, this deep dive, it really shows that integration, that core calculus concept.
Mm-hmm.
It's the mathematical engine you need to calculate totals. Totals of things like carbon that build up over time or vary across space.
Couldn't have said it better.
It gives us the power to actually measure the benefit, the environmental plus, of using things like cover crops for carbon storage in regenerative ag.
Yeah, it's a very clear demonstration. The math skills you're building right now, they apply directly to some really significant challenges and solutions.
Which kind of leaves us with a final thought for you listening.
Mm.
Okay, so beyond carbon in soil,
Mm-hmm.
where else? Where else might these mathematical tools you're learning, integration, sure, but maybe differentiation, stats, diff-EQ, where could they tackle other complex environmental problems?
Good question.
Like managing water, understanding biodiversity loss, optimizing renewables. How does your math textbook connect to the planet's future? Something to think about.